Okay, in this video we're going to be looking at page 474, section 6.6, 1 through 25 odd. But we're gonna greatly employ the properties of logarithms that we saw in the previous chapter. Certainly watch the previous video watch the video for 6.4 before you look at this. There won't be any new notes per se. We're just going to employ those properties. Alright, we're looking at page 474. We're going to be doing 1 through 25 odd. Okay, problem number 1 gives us the equation 3 to the power of x is equal to 5. Alright, what we're going to employ in this one, and very often when we're dealing with some kind of exponential function, is this idea that if we take the log of something to a power, we will simply write the exponent in front. So I'm going to take the log of both sides of this equation. I'm going to take log of 3 to the x equals log of 5. And you'll notice that I did not write a base down here. If there is no base written, it's commonly called the common logarithm or log base 10. Okay. If you only write log, what you are saying is log base 10. That's our number system is base 10, and that's the implication. Okay, but it wouldn't matter when I show this. It's not going to matter what the base is here. All right, so when we have the log of some number to some power, the exponent will simply come out in front and be multiplied by this. So this becomes x log of 3. I'm no longer going to write the base 10 down here. Equals log of 5. Alright, now I can solve for x. I can solve for x by dividing by log of 3 on both sides. This is just some number. It's a constant. Log 3 divided by log 3. Okay. These divide and leave x. X is equal to log of 5 divide log of 3. And you can evaluate this. You're going to need a calculator that has a logarithmic key, and many calculators will. You don't necessarily need a high-powered scientific calculator to do this. On my calculator here, you'll see right above where it says e to the x and 10 to the x power, you'll see it says log and it says ln. This ln we call the natural log. We say log is log base 10. Ln, called the natural logarithm, is log base e. Okay, and for our purposes we can use either one of these and it's going to yield the same thing. Alright, so using my calculator, I'm going to evaluate log 5 divide log 3. Log, it's asking for the base there, 5, divide log 3. Alright, and notice I did not enter that 10 in, and then the calculator entered it in for me, because if we don't enter in the base, the assumption is that it is base 10, and it's 1.46 is this, and I'll show I can do any base and it would be the same. This time I'm going to do base 78. Alright, 5 divide by log base 78, as long as it's the same, 3, and this is going to yield that same 1.4 there. You see it's the same value. So this is 1.46, and I can in fact could do that natural log. I'll show. Natural log of 5 divide, pardon me, I need that outside, divide by the natural log of 3. Again, it's going to be this same 1.46 value. Alright, so this is equal to I'm going to say approximately 1.46. Okay. And you could imagine that. I mean, 3 to the first power is 3. 3 to the second power is 9. So somewhere in between 1 and 2 is going to yield 3 to the fifth. It makes sense that 3 to the 1.46. And I'm going to show that substitution. Okay. I'm going to substitute this value, 1.46497, into this equation. You'll see it satisfies it. 3 to the power of 1.46497. That's going to be close to 5. Again, this has been rounded, so it won't necessarily be exactly 5, but you can see there it is. All right. 3. What we're saying is 3 to that power will be 5, and you see that it is. Okay. That's number 1. Many of these next ones are going to be exactly the same. 1 through 8 you'll handle exactly that same way, but we're doing 1 through 25 odd. I'm now skipping down to number 10. Number 10. This will be very similar to your number 9, like 9. Okay, number 10 says 9 to the power of x plus 1 is equal to 3. Well, we could handle it in a similar fashion that we did this one, all right? But this one will be easier if we could somehow manage to get these two base numbers the same. Then we could just set the exponents equivalent. You might remember from the earlier video, we had something like this. 2 to the power of x equals 2 to the power of 3. Well, since these bases are the same, I can simply set these two exponents equal to each other. If 2 to the power of x is equal to 2 to the power of 3, then x must be equal to 3. That should be clear to you. So here, if I could somehow manage to get this base 9 and base 3 looking the same, well, then I could simply set the exponents equal to each other. And I'm going to do that. 9 can be rewritten as 3 squared. So 3 squared, I'm going to put this in parentheses just so you see. Isn't 9 3 squared? All right. X plus 1. So all I've done from this line to this line is change. This should be a 9. It looks like some kind of crazy Q I've written there. 9 is equal to 3 squared. Well, now our properties of exponents say a power to a power. We can just multiply these together. So I can multiply this 2 times this x plus 1. So this becomes 3, 2 times x plus 1. That's our power rule of exponents is equal to 3. Now it's exactly like this one. Here the base is the same. I set the exponents equal to each other. Here, since 3 is the same as 3, then these two exponents must be the same. Well, this one has an implied exponent of 1. To say 3 is the same as 3 to the first. Thus, this exponent must be equal to this one. This equation becomes 2 times x plus 1 is equal to 1. And this equation we can readily solve. Distributing my 2 gives 2x plus 2 is 1. Subtracting 2 from both sides gives 2x is minus 1. And dividing by 2 yields x is a negative 1/2. Alright, we're going to take this x as a negative 1/2 and substitute it in, and hopefully we'll see that it satisfies the equation. So substituting x to the negative 1/2 into this equation, we have 9 to the power of x plus 1 is equal to 3. Substituting negative 1/2, we have 9 negative 1/2 plus 1 is equal to 3. Well, negative 1/2 plus 1 is 1/2. 9 to the 1/2 is equal to 3. And that is indeed correct. Hopefully you remember that to say 9 to the 1/2 is the same as saying the square root of 9. And indeed, the square root of 9 is 3. Okay. This is true. This is a value that makes the statement true. We just have demonstrated that this is a solution. Okay, I will show that 9 to the 1/2 is indeed 3 using my calculator. I'll verify that. 9 to the power of 1/2, 0.5. It's 3. Okay. So that will help you with many of the remaining ones. With these two problems, taking the log of both sides and making this base change, you will be able to handle the rest of those problems.